Bale. Welcome to the channel. Alright, so I've been working for a couple days trying to get this sphere to spin using the trigger coil. I haven't been successful. I think I'm going to make a bigger coil and to have this kind of sit in the middle. And we're going to start there. A little bit bigger coil. But I made this like a ball that it can spin in. Like put it on top of the coil and kind of focuses the energy. But I want to, it's gotta work, and it hasn't been working. So I got some Hall effect sensors on the way. Now what I got, the idea with that is, I might not be able to use the bowl, but maybe this.
It's hard to see that it's spinning, but it is spinning.
Yeah, it doesn't spin for very long. But the idea here is to get the drive to pulse and spin this. And the idea of the bowl is to keep it in the middle. So, but if I do it like that, I think there's way too much like distance now between the actual coil and the magnet. It's not on, basically. Here, let's turn it on. And we're going to turn it all the way up to 12. The light doesn't even come on until 10 volts, so, I mean, 12 it is. Alright, so this is the first time that I've actually used an electrified wire to, light something up, like a light bulb. All my coils have been induction coils, where when the magnet passes, it generates the electricity. This is different. See, because if I turn it down, takes no. If I turn it down to like 9, look what happens to the light. It's off.
Okay, so it needs to be above 9.
And the magnets are still passing and everything's still going on, but the light's off. So it's not using the induction of the passing magnets, it's electrified through the negative spike of the SG Bedini circuit. Those two up there and the white rotor, haha, yeah.
These two.
Yeah, those two. They each have a pickup coil, and they're each hooked to a Bedini SG circuit, which dumps into this pulse motor side for side. And that's a 0-1. The white pulse motor is set and offset because it's 9. It's 9 magnets. So, when you line it up at 180, you got one set and one offset. So I think that's pretty cool. So I'm going to turn it up to like 15. And I'm going to try and get this going. I think I'm going to need the Hall effect though. It's only a 100 turn coil of 20 gauge doing this. Might not be enough. Wow, I think it actually had an effect though.
You saw something?
On the amps. No.
Oh, on the amps.
No. It's not the ball anyway. There is an effect on the amps, but it's not the ball. My bad.
It's alright.
Alright, so again, I was thinking making a coil where this will just sit in the center. And then, or where were to go? This will just sit in the middle. And we put the ball in, and then, you know, we can make it spin that way. But I think I'm going to have to print a special bobbin for this.
That light looks cool.
Heck yeah, that's nice and bright.
Yeah.
So this rotor right here is north-south, north-south, north-south.
That is beautiful.
The first rotor, or the white rotor, is monopolar. It's all north. Actually, we're not using any caps or any batteries, so I don't think we're going to be blowing anything out.
All right.
I tried a 100-volt capacitor the other day, and I'm not doing that.
Yeah, that was scary. Hey everybody, welcome to the channel. Thank you for dropping in. Drop us a like, subscribe, leave us a comment, let us know if you have any questions about these pulse motors.
Yeah. I wonder what's Jenny doing with the kids. I don't know, I always wonder. Said she was going to the UPS store. Wow, that actually jiggled around a little bit. Here, let's try getting it right in there. There's some juice in there to keep it lubricated. But as far as I can tell, there's like zero activation in this coil. So what I'm thinking about doing is maybe swapping one of the SGs. For the power that I have going in to this coil. Let's try that.
All right.
I'm going to turn it off because
Safety first.
The guy's got me superstitious now. I mean, we're going to have to turn it off every time. But the green clips are the SG spike. And the yellow clips are power from the power supply. I'll have to come back to that real quick.
Okay.
And it's different. It's really quite a bit different, the power. All right. Well, we got a solid. All right, here we go.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we're working with magnets and electromagnetism today.
Yeah, I don't think this coil is going to push it, but the idea is sound.
Yes. These are pulse motors. Let us know if you have any questions in the comments.
All right, I got one other option here, and that's this coil. This is 100 turns of 20 gauge with a trigger strand of 500 turns. This is 911 turns of 26 gauge as a drive, and two of the same length, 30 and 32.
Nice. What's up, Mike?
Hey, Mike. Woohoo! How's it going, everybody? All right. Let me get these all unclipped real quick. I'm just going to put that bowl, this bowl,
Yep.
directly on top of this coil.
Okay. Hey everybody, welcome to the channel. Thank you for dropping in. Drop us a like, subscribe. Let us know in the comments if you have any questions about what we're doing.
All right, let's get this hooked up. Power in. Collector. All right, main drive is done. I think we're going to start just with the 30 gauge. Because it's 911 turns, that should be enough.
Right.
Right, 30 gauge. I'm going to see if I can't get a response just from the magnetism and the trade coil. Test that. don't like that. It's got like, it's got a negative reading, and it's not registering any difference. But I think because we're using the negative spike, that this trigger coil will become electrified as well. So let's turn it on. Oh, yep, there it goes. Well,
Oh, I missed it. My bad.
well, it should like be on. There it goes.
I'll keep it here.
There it is.
Negative spike. Yep.
Well, if it's registering negative,
Does it matter the way you spin it?
maybe. I'm not exactly sure. Let's turn it. Can't spin it the other way.
Okay.
So I would say no, not with a trigger coil. I got some Hall effect sensors on the way.
Hey everybody, welcome to the channel. This is Papa Bale. Drop us a like, subscribe. Let us know if you have any comments about what we're doing here.
Alright, so the negativity, I'm wondering if I have the right stuff plugged in here. Or if I should swap. Here, I'm going to plug it in the other way. I'm just going to turn this around. I'll show you what I do. Alright. Well, it looks like we still got a negative reading. So I think we need to definitely start from the bottom up. We're going to make it so the bowl will fit in the center. Yeah, because the trigger coils I'm using are giving me a negative reading that is 0.07.
What if you turn the coil over?
That's not going to change the connection.
Got it.
But I'll try it for the spin. Maybe the reaction it'll have on
Right. Oh, and I see the wires are going on. Same. Okay. Hey everybody, welcome to the channel. Thanks for dropping in.
Yes, hello, hello. Is it a time? Not yet.
That's not machine yet.
This is extremely weird because sometime yesterday I was getting positive readings that would change periodically when I would spin this. So I think I'm going to try the 32 gauge strand now. We'll just, because it's such a hodgepodge right now, we're just going to pray that I got that right.
Black Hole King asks, "What are we doing?" We're trying to get this to spin with electrical current, the sphere magnet.
Minus 0.1. Wait. That functioning. Let's see real quick. I can't even get this little coil to trigger with the ball, so maybe the ball's too thick of the plastic. I don't know. It's only 1/8 of an inch. Yeah, that's all right. I'm definitely going to make a new coil for this project, though. I want that ball to spin because I know that the sphere will create the greatest revolutions. It'll be awesome. Maybe something a little bit bigger than this. So that ball will just
Rest right in those.
sit right in there.
Yeah.
I also got Hall effect sensors coming. So we might even try something different. Kind of even in the mood to try this, but
How many files on that one?
10.
10 filer.
But yeah, I can't get the trigger coil to illuminate or electrify properly right now.
I wonder what it is. Yeah, definitely more amps. He loves amps.
Sure, heck yeah. Well, I'm not really drawing that many amps with this. I get up to about 1.5 amps. And that's all the way up at 15 volts plus, thereabouts.
Here goes the dampage.
Wouldn't know the first thing about building a bomb.
Right. Pulse motors, electromagnetism. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we are working with pulse motors and electromagnetism today.
Absolutely, that's what I mean. It's going to be, well, just a coil, really. I mean, essentially it'll be a Newman motor, but it's just a big coil. Well, the speed of everything is keeping it cool, so that's, thumbs up for me.
You want to talk about the cores?
Yeah, I printed those cores. They're 45% iron. And so it's a very low magnetic flux, but it's perfect. So it doesn't like suck everything down, slow everything down. It's absolutely perfect, I think. It's very slight magnetic pull on the rotor for like a greater magnetic flux than I could hope for.
Hey everybody, welcome to the channel. Thank you for dropping in. Leave us a like, subscribe, drop some comments. Let us know if you have any questions about what we're doing here.
Yeah, heck yeah, man. Whew. Yeah. Well, I mean, the negative electricity, the negative thing I'm getting here, I don't get it.
And that's reading that coil.
This is reading the trigger coil in this coil. Yeah.
Yeah. Okay, got it. That's right. There's multiple coil.
Absolutely. So I'm thinking I'm going to make it out of 22 gauge, and I'm going to have a trigger coil wound into it just to try to use a trigger coil, and then I'm going to have Hall effect sensors, you know, put it in here like this. On your Hall effect, have it on the coil, run your Hall effect, you know, it's like that. Should be righteous, but I don't think I have a coil designed to spin that ball right now. I'm gonna move that because that light's gonna get hot.
Okay.
I'm gonna move that negative spike thing back over this coil. I'm just happy how well that's performing on the on-off positions. We'll get some Tach readings here real quick.
Peace and love. Thanks, Trojan.
Peace, my man. Alright, so Tach is over here. I love how the north-south is actually functioning.
Yeah, it looks smooth.
I'm thinking right around 650.
Anybody want to guess the speed? Close. 630. 740. Here, run it again. We'll do a 3. Average of a 3. All right. Yep, and it's still going up. Nice. How about this one?
There's no strip on it.
Oh,
We can do magnets though. Divide by 6.
divide by 6. How fast is this one going?
1930.
1930 divided by 6 would be...
Slowing down though.
So a little over 300. So this one, there's an illusion with that one. And is there maglev? Sorry, finger. Is there maglev on any of these?
Yeah.
Yeah.
They're homemade maglevs
There we go.
on some toroid magnets. So they're just resting on some toroids. Nothing around the shaft. I'd like to get some magnets with some 1/4-inch holes in them. That'd be awesome.
Yeah.
So this is steadily slowing down.
Hmm. Hey everybody, welcome to the channel. Thank you for dropping in.
I got an idea.
Leave us a like, subscribe. Let us know in the comments if you have any questions about what we're doing.
Just for now. Oh, we're gonna swap them out. Now these magnets are at least 5 times stronger than those magnets. There's only 4 of them. And this has got a maglev as well. Oh hell yeah. Hear that?
Thank you, Black Hole King. Post as many comments as you can, and we review all of them. So we'll do the research spots after the lives.
Now this is monopolar. They're both monopolar now. Where did I put it? Here it is. Let's watch this one. This one does have a strip on it.
Anyone want to guess about how fast this one's going?
And that, it's 400 now. 400 RPMs.
400.
But it was very rapidly increasing in speed.
Okay, so it hit a fast acceleration phase.
So we're at 470 now.
Okay. Hey everybody, welcome to the channel. Thanks for stopping in. This is Papa Bale, and we're working with electromagnetism and pulse motors today.
All right, we're going to do a magnet. We're going to try and get to just straight 2400 and divide by 4 for 600. Boom,
Oh.
600.
600 with it accelerating.
Yeah. And I mean, if you just look at the way this stuff is built, I did the best I could, but you know, 841, that's pretty good speed. 842.
Beautiful.
And it's 16 volts in. I know I mean, I think it's awesome. Like, awesome. It's not great, I know that, but I think it's great.
Nice. That's like 1.5 watts.
Really? Yeah.
Oh wait.
No.
16 times 1. That's
Yeah.
probably 15 watts. Excuse me.
Yeah.
Excuse me.
I was like, dang, this is good for 1.5 watts.
right. Order of magnitude.
So, you know, with the ball, I tried this bowl, but it's got like a concave thing going on here where the center is risen up, and it won't work very well.
Okay.
I tried this cap. You know, I tried virtually everything that I have right now.
— 12-volt.
12 12 volts. And that's literally 6 watts basically.
Right.
Right now, what's going in. A little over 6. So not every coil is tri-filar yet, but I'm planning on doing tri-filar coils. And then that third strand, you got your trigger strand, you got your drive strand, then you got a third strand that's just hanging there, right? It becomes electrified at around 10 volts. And then you can run stuff with it. Like this light is being run by the third strand in one of those coils. God bless. All right. So, and like I said, right around 10 volts is when all the extra stuff starts happening. So when you turn it up to 9 and nothing's going on, but your motor's spinning and everything's okay, just because nothing's going on just means you haven't turned it up enough. And at 12 volts, it's still moving like water through a hydro plant.
It really is. That is smooth and beautiful.
So I was thinking about making another rotor with either 8 or 10 magnet slots in it instead of 9. And that way, I think it'll time right with all the stuff we're doing. The 01 is what it's sitting right now.
This one's 01.
Yeah, 180 degrees is set and offset positions. It's a 01 pulse motor. It's set and offset at 180 degrees. It's a 9 magnet rotor. Trying to think now. Yeah, I really want to make this coil. It's like the only thing I've really got to do right now is get this ball spinning. This is my power supply right here. It's got 12 volts, 0.6 amps going in right now. .5. Oh,
Nice.
Oh, yeah.
6 watts.
Right now I'm just seeing what works and what doesn't. I don't really have a goal necessarily. But I'm going to try it all. I'm going to do everything. I might not get it. It took me a year to get this and like into my memory. Is that like dropping a battery down a copper tube? No, I haven't seen that. I've seen the battery go through the coil as like a train, you know, like ring and it'll go all the way through. Seen that.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. We're working with pulse motors and electromagnetism today. Leave us a like, subscribe if you love this kind of content, and let us know if you have any questions about what we're doing in the comments.
Yeah, man. That train coil battery thing, blew my mind. It was like awesome. I was like, how are you doing this? Um, yes, yes indeed. We got the Ender 3 version 3. This currently is a Bedini style project with the SSG circuits on either side, kind of tapering down the table. From that pulse motor on the end to this pulse motor. So those two Bedini circuits on the end are firing off on these two coils to run this motor over here. Thanks, Pete. Yeah, I mean, if you understand it on like an individual level, like on a magnet to coil level. See, there's 9 magnets in there. There's 2 coils out there, but on a coil to magnet level, this I would say is where the railgun started. Yeah, twin Bedini. Yeah, usually it is the part where it breaks. Actually, you're quite right. But I've changed up my engineering a little bit, and I've made it so they're not going to break.
Yes.
So the faster they spin, actually, the more stronger they get, basically. So, man, I don't know, maybe this coil would work. Got
Thanks for the sub, Censored.
Thank you. Oh.
He makes all of his own coils. Do you know who Dez is, bro?
No.
Okay. And then yeah, tell them this.
You got 4
How did you
24 gauge. What's tell them what?
How did you start this? What was your path into pulse motors?
Well, no. I'm gonna start off with how I started out making coils, multi-filar coils. There was, a test done on a series of coils, and it was found that the 50-turn four-filar 32 gauge coil could do about 738 RPMs. It was the fastest coil out of all these coils, and there was like honking, 5-pound coils, all this crap. And the little tiny one was the one that was the fastest and literally the best. And so it was for speed though. This was RPMs per watt. And I forget who the guy was that did the video, but I was like, yeah, I'm gonna do that. I'm gonna see if cause I never actually got the 50-turn one to work, but it led to bigger and better things. in my mind. Now this is there's four 24 gauge strands in here, and there's four 26 gauge strands, and there's two 30 gauge strands. So you can break it down like 2, 2, and 1.
There it is.
And have two series. And there's like literally 10 or 12 different ways you can hook this thing up.
Right.
So, and for the most power, I would hook up each coil gauge individually. And I'd use the two 30 gauge strands as a trigger. So I'd have two literal like 800 turn coils of 24 and 26. But like if I wanted to break it down, it's 200 turns. This is a 200 turn coil. So I could have a 200 turn strand of 24, which is actually quite powerful.
Mm-hmm.
Or I could have an 800 turn strand. Yeah, I hope they're all right. They just went to but right now they're all hooked up in series. But that's kind of like the idea of what I would do.
Here, let me get that question for you from Legendary.
Yeah. Okay, so the one coil powers the other coil without a power supply. No, absolutely not. Without a power supply, none of this stuff would work at all. You could spin it, and it might spin a little bit longer than it would without the coil being there, but that doesn't really count. That's just, there is some motion there, but it's not going to run. It's just going to make your spin last a little longer. $700. Heck yeah, the ohms add up in parallel. Yes, that's so true. The ohms add up in series. The amps add up in parallel. So what I could do, I don't know if 400 turns of 30 gauge is going to be enough of a trigger. What do you guys think? Should I try it? Let's see. Alright, so these are hooked. Right here, this is the one I need to undo. Alright, so what it is each of the same strand is hooked in an AC series, and then the coils are linked together in DC series. If that makes sense. I tried linking them all together in DC, and it's nothing, man. I don't even bother trying.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe if you're enjoying the content. Let us know if you have any comments or questions in the comments about what we're doing here.
I just need the 10 on this side. That's the 10 on the other side, so I need the 10 on this side. There it is. Now I need to hook this up to it. Right.
So can you give us a breakdown and just what direction are you taking it?
So I hooked up, I'm trying to get the trigger to trigger with this ball here.
There it is.
Okay? And here we go. I think we might have a good situation here. Alright, let's see if we get any readings on that. No. So I'm thinking this bowl is a little too thick. I don't know what's
That makes
wrong.
sense, yeah.
Yeah, I don't think 400 turns is going to be enough. That's all right though.
So what is the ball supposed to be doing when it's working?
It should spin really fast in the center, and yes, it can levitate if it's spinning fast enough. But I think the Hall effect sensor is going to help out a lot.
Appreciate the questions.
It's all right. I'm not discouraged.
Awesome.
So it's got to be bigger than that. Like the cap, this cap has got to fit inside the center of the coil, and it's got to be about 22 gauge. The 10-filar coil, I've had it hooked up parallel. It's pretty neat. I mean, after about the 8th strand being hooked up, it kind of fires back on itself though. In a parallel, in series, or the way it's hooked up right now, it is very strong. You get 24 volts, 0.1 amps maybe.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. We're working with pulse motors today. Drop us a like, subscribe if you appreciate this content, and let us know if you have any questions.
So maybe if I put it in here, move it around like that. We're getting no reaction on the meter, which makes me feel weird. I mean,
We got a question from fam.tech. How did you make that?
This or the whole thing? For a bowl,
Fam.tech says it's the whole thing.
the whole thing. Well, it took about a year and a half to get it all together and learn how to do it. Some of it's 3D printed, some of it's bought from the store. It's always changing. So this might be different tomorrow, actually, like totally different. I clean up this thing like every day, 2 or 3 times a day. It's a pulse motor. Currently we have that pulse motor powering this pulse motor, and I'm also trying to spin this ball on top of this coil at the same time. So it's pretty cool. There's only two active connections to the power supply right now, and they're connected to each one of the coils on the end there. Yes, and the white one over there. Yep.
9 mag.
Oh, I'm not looking to do like. I'm definitely trying to get either 8 or 10 magnets in the next rotor. But this is definitely a thing. It's my thing. And I actually was inspired by somebody when back when I started. He's like, you should do a 9 magnet rotor and you should make 32 gauge coils to power it. And I was like, okay. And I started there, and that was a good motor.
Yeah.
Whose motor is that? Pete, is that your motor? It can power anything. I mean, it can power a Tesla coil, any like thing like this. If you're looking to power a refrigerator, go plug it into the wall. Because we're going to make plugging things into the wall a lot less expensive than they currently are.
Yes. Yeah. Yeah.
See all those city-sized batteries out there? Those are helping the current power supply, power grid, cope with people plugging stuff in and making the price go down.
That's right, because the peaker plants, although they're still firing
Let
up,
economics take its course, people.
they are being, the dependency is being lifted from these batteries for sure.
Yeah, and you know, and it goes both ways. You know, people trying to stop it from happening and people over advocating for it. You know, it's bad juju both ways. Creature?
Creature.
Sure, it's definitely
Got a mind of its own.
yeah, it can take out an army, no problem. No, I didn't say anything about free energy, dude.
That's a pet peeve over here. Those are
I didn't say anything about over unity, and I didn't say anything about free energy.
free energy and over unity is the same as Voldemort over here, yo.
There's everything that you can do within the laws of physics. You don't have to break shit just to do something. Even changing the speed of time is within the realm of physics. Okay? It is. You're not, it just, come on, man.
Yes, that's it.
Yeah.
And the pulse. We love the pulse.
What does it do? It takes the 12.3. See, it's already not free. And it takes it and it disperses it around. And even if it's exponentially, like there's a gain on it exponentially, it's still not free.
But the exponential gains are definitely a goal.
I'm advocating for doing all this without breaking the laws of physics. You don't have to do that. It's a trigger coil. Yo! It's wrapped inside the coil. I wrapped them parallel from the start.
Welcome to the channel, Poppy.
And so when the magnet passes the trigger coil, it sends a little impulse to the base of the transistor, and it's just enough to turn it on and turn it off when it passes.
Nice. Nice explanation.
Sometimes 30 works good, sometimes 32 works good. So in the tri-filar coils, I put both strands in. Thank you. I appreciate that. Now, I was thinking that if we use these coils set up and we put them all the way around, we could probably get it to spin for like 15 minutes, just on a spin. So that would be one coil dumping into the next coil, into the next coil, into the next coil. But I'm figuring that each time it dumps into the next coil, it's going to be a little bit less each time. That's what I'm going to guess. Trigger coil with me is standard, probably around 10 ohms, maybe 15. But my coils are small, so I don't know how you would gauge that. Being, because I know the bigger coils, you're going to end up having a lot more ohms. Yep, just the 230 is the trigger coil.
Thanks, Censored. Appreciate you. Have a good day.
Thanks, Sensor.
Oh, let me get that question up. There we go. Oh, you answered it. Okay.
Yeah, in this coil, the trigger is just the two, and typically with these, I was running an external trigger coil. A trigger coil outside of the drive coil. So, and it's actually, can produce phenomenal speed rates because you have the timing issue. You can time it when it's not wrapped up in the coil. So I don't know, I'm kind of an advocate for trigger coil outside. I like trigger coil inside too. I do a lot of both. So like, I would actually like to hook that up and see how fast, with all this stuff, we could get that going with an external trigger coil. Oh my God, I'm just thinking about it. It's blowing my mind right now. I'm probably not going to be able to do that today, but...
That does sound exciting.
Oh man. So they went out to eat.
Ah.
That had to be it.
Like an Applebee's kind of thing.
Yes.
Okay.
Either that or it's a long line. All right, so I would hook up all of the coils, all 10 strands in a series circuit, and then I would hook that to the same transistor as an external trigger coil or a Hall effect sensor. Kind of have the same effect because you can move it around. Yeah. No problem, beat. It would have been a long time for me to figure that out unless somebody said, why don't you just remove the coil from the coil? And I'm like, well, what do you mean? And he's like, well, you put it over here, you can move it around. Because the timing is supposed to be perfect when it's like inside, but I'm telling you, it's not. I mean, it's good, but it can be better. I'm loving these cores. I'm really loving these cores. 3-inch cores. They don't get too hot. They're, 50% iron, so they're very low magnetism. Here, this will show you what I mean. That's how magnetized they are, and that's a really powerful magnet right there. So it's like, I think it's great just to capture the flux, and not like bog everything down with super magnetic flux, but just enough flux.
There you go, fam.
To be able to run the pickup coils on the back end. There's enough flux to do that. Now, when I put one of my induction coils on here, and I just like throw it right here, and it's not connected to any drive whatsoever, you can generate enough electricity with it to power this light better than it's being powered right now. So, there's a lot of balancing going on, And when I say induction, I mean more like transformer style, like pure generator. It's not connected to any drive coil whatsoever. It's 1 end, 2 ends, single file, 32 gauge, wrapped around a nice core. Boom, that's going to generate you 250, 300 AC volts with roughly an amp of current. Yeah, man, you can power a pulse motor, you can turn on a light, you can do whatever I want. I don't want to power my refrigerator with a pulse motor. No, I don't.
Hey everybody, welcome to the channel. Thanks for dropping in.
Hey everybody. Glad you could all make it. So, yeah, I'm really into the multi-filar coils here. I'm just wondering, quote unquote, if I take the green clip and I put it on where the yellow clip is right now, right here, will it make a difference? Will the negative spike coming off of the coil be more power than the power coming out of the power supply? I know it's not going to work because I was just testing, that's what the multimeter was for. I was testing to see if the trigger, was going to fire. And it's not even registering. So. I do know that when it's like spinning really, really fast, the 3,400 turns to 30 gauge is not going to get you much voltage. But I kind of want to try it, so. Because sometimes when I've hooked it up, the trigger strand electrifies, and therefore it's always got the right voltage, at least the right voltage to trigger. Alright, let's do this. See how powerful that is?
Yeah.
Good. And 12 volts is pretty much, we'll just do 13. Too much, but that's okay. Yep, so I gotta make it probably a 32 gauge trigger wrapped parallel with 22 gauge drive. I'm wondering if I have it hooked up right. I don't know. It's alright. I'm not, see if I have it hooked up wrong, I'm gonna let it go because that could take all day to figure out.
Right.
To go through all the clips and make sure everything's all tight and everything. Alright, so I'm trying to think if there's anything else that I could do. Maybe. There's one more thing I can try. And I know that's this coil. 250 turns of 16 gauge. And then there's two strands, so there's 500 turns of 26 gauge, which is an even worse trigger.
But it's got the thick one in there.
Yeah, it's got the power. this is the negative end of the trigger. Here's the positive end. Connected to the diode. Connected to the resistor. Maybe it's the resistor. You could take that resistor off, everything will work. Alright. Oh, we just need to hook up this part. Now see if we can't get a reading. Let's try 2. Yeah.
You got some.
Alright, so it works. Just maybe not enough. Alright. That's a good sign. That's
Yes.
response. That's a good sign.
Great work.
Let's turn it on. See if we can get it to spin a little bit.
All right.
See, it's that negative. I don't know what that is, man. Is that the negative spike? That's a very low voltage. Wow, that was a nice spin.
That went further.
Maybe the bowl will work. That would be sweet if the bowl works now. See, I printed this bowl specifically so it would stay kind of in the middle.
We got something.
I think it needs to be flat a little bit in the middle though, because it's not staying in the middle. So I'll have to print another bowl with like a little spot where it can sit in the middle, because there's no spot to sit.
Nice.
I think it's cool.
Yeah.
Because the cap still works the best. And the cap is really thin plastic, but it's not smooth in the middle. It's bumpy and it pushes it to the side. Whew. Wow, that was a good spin. I'm getting some ferro fluid coming in the mail. By the 14th I should have it. And I was planning on spinning this ball with some ferro fluid on it. Sometimes. Actually, I look at it a lot, but yeah, I'll check it out. Whirlpool, is that like a washing machines, right?
For
Dishwashers?
for dishes, I think. Thanks, MacGyver. You got some toothpaste and paper clips and some dental floss.
Toothpaste and dental floss, that's all you need.
That's right.
And a paper clip.
There we go. Appreciate you.
Yeah, all I need is a neodymium magnet and a piece of bubble gum.
Boom.
The world is saved. Wow. It really wants to go sometimes. It's almost there. It's almost there. The last second. Is that like the darkest hour? Is that what he's talking about? Who's recording? Yeah, that's good. You were right.
Right on. That's funny. Hey everybody, thanks for dropping in. Welcome to the channel. This is Papa Bale. We're working with pulse motors today, and we're trying to get the sphere magnet to spin with electrical current.
Anybody got any ideas on how to make this work? I think I just need a different coil with a more responsive trigger. And basically, it should work. It is working. It's just not perma working. Yeah, man, there are just some things that are nobody's business.
Hey everybody, thanks for dropping in. Welcome to the channel.
Hey, what's up? We're gonna do this. All right.
I think you're closer than you were last time I saw it.
Yeah, definitely. I mean, I feel like I'm getting some current through, but I think it's because it's from the negative spike that it's actually doing anything. Because the trigger is barely responsive. It's going more negative.
That's the input right there, MacGyver.
Yeah, man, if we could get it like in the center of something, like where it was not hitting the sides, I thought the bowl would be really good.
Right.
But it's like it won't sit in the middle. Maybe if I spin it like a better way, I don't know.
That first one that went all over had a big reaction.
Yeah, that sounds right.
Yep, 12.9, you got it. And 1 amp in, so 12.9 watts.
But the trigger is getting a better response. It's just like barely, but yeah. When it's moving around and not just spinning. What I mean by a better response is 0.006 positive voltage.
We're from Detroit.
And I think it's too thick.
Yeah, I would agree. You said it's an 8.
Yeah.
So you're saying print another one with a flat section in the bottom and a little thinner?
Yeah, like maybe even a 16th or a 32nd. Just enough to corral it, basically. Whew. Man, it's getting hot.
Yeah. Hey everybody, thanks for dropping in.
Thank you.
Leave us a like.
Yeah.
Subscribe if you enjoy this type of content. Let us know in the comments if you have any questions.
Yeah, I think the repulsive force of the rotor is pushing the magnet away. A little bit at a time. Alright, so I think the 16 gauge or the 22 gauge, I'm going to go 22 gauge. 16 gauge is great, but you can only put so much in. You get about 250 turns out of a pound spool, 16 gauge. Yeah, it's great though. It's kind of working.
Oh yeah.
No, thank you. Actually, I'll pass on the spaghetti.
I think we'll
I
probably
prefer
go
chicken,
or some pizza,
hamburgers.
some coney dogs.
Yeah, I've actually lost 10 pounds in the past week. So anybody with fat jokes, eat me.
Congratulations.
Thank you.
MacGyver says my input is 12 and my output is 110.
I don't have an output strand at the moment. I could check what this output is though.
Let me get up on there.
No, it's not here. I gotta move it.
Oh, okay, no problem.
I'm going to get a reading on the spike, negative spike, off of this coil. I think I am anyway. You want to turn it down?
Yep.
Yeah. Turn it down first.
Safety first.
And we will hook it up to something that's actually using energy. Alright, you can turn it back on. Wait, let me hook it up. Alright, that one's in. See, I don't know where to put the negative one though. We can turn it on.
12 volts.
Yeah.
There's the ampage.
Now, where would I... just don't know where to put this.
The negative.
Yeah. Maybe right there. Maybe that's just it. There's no way to measure this. Wait. Come on, dude.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and we're working with pulse motors today.
So I guess if we hook it directly to the negative of the power distribution, you get a reading.
Okay.
But it's only, like 6 volts.
Only 6 feeds.
You want to come over here and look at it real quick?
I got a close up.
Okay. All right, so what are you measuring for your output? I know it's not a negative spike, so do you have a coil that you're measuring?
And apologies if you did post that.
Here, let's try this.
Yeah, we have some Hall effects en route. They're out for delivery.
Wow, we're getting no reading on this. So that can go directly into the rest of the pickup coil. It's okay. I made my pickup coils bipolar just so that if I wanted to add some more length, I had the option to do that. But it's, the pickup coil's not showing me anything. Oh, wait a minute. Oh yeah, that's it. That's just a bipolar. Sweet. So I guess I could set up a way to measure AC voltage in an output scenario. It's just that I haven't measured any output lately. See this bad boy right here will generate a lot of electricity.
Yeah.
Yeah, I'm gonna try a Hall effect sensor on the ball and see if that works. All right, you wanna turn it down? Thank you.
Down.
Sweet. So, this one's got a little bit more hole to it. It's got a solid, soft core. Cool. Now this is pure magnetic induction. There's no help coming from electrification or anything like that.
Is the input DC or AC?
Input's DC. I'd love to have AC input because then I could start working with higher frequency and I could start moving with aluminum. That's the next step. An aluminum rotor, no
Yeah.
magnets on it.
Yeah,
Spinning
yeah.
like the Dickens.
Yes.
All right, sweet. Let me hook up the multimeter, and then we'll get some output readings real quick. Sick ones, hopefully. Like, oh my God, no way! I don't believe it. Kind of stuff.
Yeah.
Tape is usually where I start, so I'm going to put the red one on the one with the tape, and I'm going to put the black one on the blank one. Alright. I think Alright, you want to turn it up?
Yep. .12 volt, 0.1 amp, 0.2.
Now this coil produces AC voltage. It's going to take a while for it to get up to speed, but it's at 37 volts right now. All I need to turn it into DC is to hook a diode up to it. So would you like to see DC reading instead of an AC? Oh, I wish I had a garage. That'd be dope.
Yeah.
I would definitely be chilling in the garage if I had one. That'd be so sweet.
Mm-hmm. Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale, and we are working with pulse motors and electromagnetism today. Let us know if you have any questions in the comments. Drop a like and subscribe if you appreciate this kind of content.
Oh, we're rising slowly, surely.
Oh, let me get the readings.
See, these are just 1-inch cube magnets, though. I usually use the magnets that are in this rotor, which are 40 millimeters by 20 millimeters, and they usually get that reader up like a ridiculously
Right.
fast amount.
Yeah, in seconds.
Great, yeah.
.56, 57.
That coil is 18,000 turns of 32 gauge. We got 60 volts yet?
64.
Wow, hell yeah.
It's going up quicker.
Hell yeah. No, I'm gonna let the world like sort itself out, I guess. I might like take a trip though, to come back.
70 volts.
At a different time, space. So you're like, yeah, I took a trip, came back. Now my name's on everything.
Yeah.
See, all I had to do was advocate for the mile. Go back in time and advocate for the mile. Yeah. What do we got now? Voltage. 78. Holy cow, we're gonna pull 80. That's awesome.
Yeah, here it comes.
A Gundam suit. Ah, Sally.
80 volts. Drop us a like if you like that.
A Gundam suit, huh? I'm not even sure. Gonna have to hook this coil up differently.
Right.
Maybe with a smaller transistor
Mm.
that doesn't need as much to get it going. Like a 2N2222. That might work.
Right.
Alright, what do we got on the bolts? 85. We haven't changed the input yet.
Here's the mag lab.
We're gonna plateau, I think, with the bolts pretty soon. Right now, we're currently drawing AC volts from a coil that's hooked up to a pulse motor that's being run by 2 Bedini coils and SG circuits that is running another pulse motor at the moment. That's what's going on. I hope I got that right.
And I was just pointing, following along. And here we go.
It's slowing down.
Yeah, it's definitely slowing.
And you have a 12 volt input. What's your frequency at? Just curious, MacGyver. Yes, our goal is your goal. Your output is our goal.
It's leveling at 88.8, bro.
That's freaking so cool, man.
Yeah.
Maybe that's gonna be our goal.
That's a really, really lucky number. And we're so close to 8.8 today. Oh my god, is it the 8th?
Yeah.
Oh my goodness, you guys. 888 on 88.
I love how easily the negative spike pushes the second motor.
Yep, we peaked. There we go.
Oh, it's peaked. Okay. We're not going to make 110. Not at 12 volts. Not the way it's set up. How close is the coil to the motor? We could probably eke out another 10 or 20. How close is it? That's as close as it's going to get. Probably get. It won't get any closer without messing it up. Shoot. So yeah, 88. 88 miles per hour.
Yeah.
Oh, dude.
So cool.
Oh, man. Where are my kids?
They are with mom, and they're having a good time. Maybe.
I hope so. No, I don't know whether, because we're supposed to get Page's instruments tonight. I hope I don't have to go there on my own. So we're going to take 12 volts of DC electricity at 0.6 amps.
Wow. Nice. They found the center, bro.
Yeah, I saw that. See, I mean, it wants to work. It just isn't triggering. So I think a Hall effect sensor would work really good with that.
Yeah.
No, the goal is not free energy. I'm using a lot of quote unquote free energy stuff though. The goal is not free energy. There's always a cost. Even if you don't know what it is yet. And if you think you got free energy, there's always something that you're overlooking that you haven't looked at yet. It's part of the equation that you just didn't put in the equation.
Yeah.
And that's why I'm saying that all this stuff is within the realm of physics. Without breaking any laws, you can time travel. You got to understand things the right way in order to do that. You know, and I'm not saying I can do it. I'm saying if I learn enough, I'll do it. Whatever. I'm doing everything that comes my way.
And you're willing. That's
okay,
what
I will.
That's what you just said. I'm doing everything that comes my way. Yes, sir.
And I might not get it the first time, or the second time, or the third time. I might not get it until somebody's calling me, "You're a stupid idiot," and he's just frustrated, or she's just frustrated as hell with me, now that I don't get it.
Just right here in the comments.
And then the next day, I'm gonna get it.
Yeah.
And it's gonna happen. And I'm gonna make a video about it.
Mac MacGyver asked, how long have you been working on these?
Year and a half. I've done a lot of different things. I got about 200 different rotors. I've got all different kinds of magnets. I got lots and lots of different kinds of wire. I don't have any bulk wire right now, but I've made over 500 different coils, different style coils. Like, and no, it wasn't free.
Yeah, all our energy has a kilowatt hour cost associated with it. Appreciate that, Christian.
Thanks, Christian. This right here is a pulse motor. Now, there is a movement to create something that might be able to ripple the fabric of time. At least that's what it's said to be able to do. And that's this right here. In between, like every other hole is going to be covered with aluminum. And then there'll be aluminum, kind of like, it's called an utron, and it's circle from one side and square from another. So it's a very specific shape. It's two cones that come together, and all the dimensions are the same on all sides, basically. And 6 of those will go in here. And I'm working on an electromagnetic coil that will trigger the utrons. So it'll kind of go like this.
There's good. Yeah.
And this will spin, and this will spin the other way, so it'll be a gyroscope as well. But I'm doing this just from looking at a frickin' picture, basically. I mean...
And eyeballing it.
Come on now. There's like some information about the Utron, but basically I'm having PCB Wave make me 6 aluminum Utrons if the first one turns out good.
Yeah.
And that's going to cost me about $350. And they're only an inch by an inch by an inch. And this is not a craft, okay? This is just something that might ripple the time in front of me. It's not something that I can ride. When I say ripple the time, it means it connects to the ether. And then basically you are all places at the same time. If you get what I'm trying to say. Like, for instance, a good example, I always thought a good example was you have an object, you know, in front of your face, and then you can put another object in that same spot, but you can't put them in the same place at the same time, because the laws of physics, the Bale, I don't know exactly what it is, but in this reality you can't do that. But beyond the third dimension, there is something beyond the third dimension. Everything is everywhere all the time. If you get what I'm trying to say. That's the only way you can move from here to here is because you're already there.
Hey everybody, welcome to the channel.
I know that's really hard to wrap your mind around. I mean, it's hard for me to explain, so.
Thank you for dropping in.
Thank you.
This is Papa Bale. Like and subscribe if you enjoy this kind of content. We're working on pulse motors today. Leave us a comment if you have any questions.
What's the battery like?
11%.
Want to jack up?
Yeah, I didn't even see that.
Actually, it's not capacitors, it's an accumulator that collects and disperses the energy that's gathered in the contraption. So it's like a big neutron in the middle that's spinning really, really fast. Me and a buddy of mine, we've been looking into it, and I was wondering, you know, I got this aluminum wire here, and I was wondering if I could make some kind of accumulator with it, you know, like wrap it really tight, really like a 1/4 inch shaft, wrap it really tight like around the shaft, and use this as an accumulator, but I don't know. I mean, this is not covered wire. This is all one. This is not enameled. And so it would like rest on top of it in a nice tight ball. And it would spin. I'm not sure whether it probably spins with the rotor. And then the neutrons and the accumulator interact with one another, pulling and giving energy constantly. Yeah, I've done that before. Believe it or not. It's like an extreme 9-volt battery tongue thing. Like extreme, though. It's hard to let go. No, I don't do it for fun. It was an accident. Well, I was 3 years old, so I mean, God, I guess I'm lucky to be alive, right?
Yeah. Yeah.
So for the aluminum spaces, I have this is 0.2 millimeters thick. Probably not thick enough to generate the eddy currents that I need, but we're going to start somewhere. Yeah, what I'm getting into is really, really powerful stuff, man. It is going to be moving things at very high frequency. It only works at high frequency. That's basically what I'm saying. But I love my coil right here. It's a 14 gauge. It's a bipolar coil of 14 gauge and 18 gauge. So this thing will literally go 20 amps. I'm pretty sure, something like that. Something crazy amp wise when you turn it on. But I'm gathering that in order to generate eddy currents, I'm going to need AC electricity, not DC.
And MacGyver definitely said the Whirlpool stator will give you that AC input.
Heck yeah, man! I'm going to need to get into that. Whirlpool stator.
And then he's getting it to where he can run his house on it.
Well, that's going to be dope. Fill me in on how far you get with that. Have you actually get it to work, man?
I'm not sure what that is, but I think we're good.
All right. So this is a 4-magnet monopolar rotor. And this is a 6-magnet bipolar rotor. So we're going to hook this one up.
Want me to cut it?
Yeah. And we're going to see what's going on with this. So this is a Celtic Cross design. It's monopolar, so all the magnets are being pressed by magnetism to the outer, pushed out, and then inertia also pushes it out. So this is a pretty safe rotor right here. I'll put it down so I don't. Those magnets are so powerful though. They come together, you're definitely going to need to pry them apart, or use one of your wood contraptions to pry them apart, basically.
Maglev.
Yeah, try and maglev them all the same way. One time I maglev one differently, and it just, of course, it stuck. So, I don't know.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. We're working with pulse motors today. Appreciate your comments. Let us know if you have any questions. Welcome to the channel, Ragu System.
Hey, what's up, my man?
Bobby Gould, welcome.
OG scientist. I roll my own coils and among other things.
That was awesome. That is cooking. It's spinning.
$20, 60, 70 volts. so far. Now, I don't know if the pickup coils are actually, because they're hooked in series to the main drive.
Mm-hmm.
So it's just like an elongated coil on the core, and they're supposed to make it go faster. I think it is making it go faster.
It sounds like it. It's hard to visualize it for me.
85.
Oh yeah, that's right. We peaked at 88 last time.
And that was 12 volts in.
And we're at 13 now.
So this is one more volt, and we're already up to 90.
Yeah.
And that coil that's being tested is this one right here. I got it. 95. See, it's amazing at like what actual voltage, like there's thresholds of speed. Like when you hit 13, but when you hit 13.1 and that amp, that 0.1 amp goes up, it just goes like 20 more RPMs per second. Oh, I wish I was still away. We don't have any batteries here.
No batteries. But we are plugged in. 13.1 input, 0.7 amp.
No free energy. Definitely, everything here has a cost, and he just showed you what the cost is.
Yeah.
Now I'm pretty sure we can light up more stuff than with anything. You know. Right now, this coil is generating 100 volts. Volts.
Nice.
AC electricity.
Welcome to the channel, everybody. This is Papa Bale. Thanks for dropping in.
Hey, 111. All right, welcome. Now we have SG circuits hooked up to both of these coil setups right here. And then the negative spike is being dumped into the next pulse motor and their respective sides. I'm pretty sure that pulse motor would run on one. I'm pretty sure this pulse motor would run on one, but it's not enough. You always got to have something to do, so I built, another coil.
Yes. He loves building coils.
But I think I'm going to do final build. Coils are probably going to be about a ½ inch bigger than they are. Probably around the same axle. But I'm going to do 22 gauge and 32 gauge. 22 for the drive and 32. I'm going to do 2 strands of 32 actually. So it's a tri-filar with 32 for a trigger and then 32 for an extra light. See, like this light is being lit by an electrified wire. There's no induction necessary to light this light.
I gotta take a bio break.
All right, here.
Thank you. I'll be right back, folks.
All right, so at 13.1 and 0.7, we're going to turn it down to, oh, that's my amps. We don't want to turn those down. Turn the volts down to 9. The light is off. But the pulse motors will still run at pretty significant rate. Like those aren't stopping. Just all the lights are off pretty much. But then when we electrify the wire at about 10, we'll say 11, 0.5, it's on. Very dimly though. It's tied directly into the input that I put into it. So, and it is kind of the other way too, directly tied into it. Yeah, I'm going to put it up to about 16 just to show you what the third strand does in the tri-filar coils. Look at how bright that light is now. Okay, and that's just from a negative, or no, it's from my third strand in the second pulse motor. So, I mean, here we go. I was just demonstrating something. We usually run around 12 volts. But if we look at the light at 12 volts, see how much dimmer it is?
Yeah.
I mean, it's still working, but it's a lot dimmer. Thank you, Thomas. Yes, pulse motor. (102 AC volts). It's going to drop down to 88 miles per hour.
88. Here's the input.
Kinda power management, I guess. I'm just showing you how it's not electricity like this, where it's generated by the magnet passing through. It's electricity that's tied directly into the input, although it's not directly tied to the input. So it's electrified. You get what I'm saying?
Hey everybody, welcome to the channel. Thanks for dropping in. Like and subscribe. Drop us some comments. Let us know if you have any questions.
I'm just happy to see this thing going at least 1,000. I've seen it going 1,000. Hey, Death Rider. I'm spinning some plastic, some magnets, copper coils. It's a pulse motor. We're pulse motoring down the merry way.
3D printed parts.
This here is a 9-magnet monopolar rotor. This one. And this one is a bipolar 6-magnet rotor. So north-south, north-south. This one's pretty badass.
Yeah, that is smooth. All maglev.
Hey, Mr. Impact.
Right on, we like nerding out.
Heck yeah, man. All right. Even though I gotta make money with my mind, I still think I could.
You still think it?
No, I still think I could. Never mind.
Nice.
All right. So, wow, that was fun. I really liked explaining all that. I don't know if I got the light explanation well enough. Oh, I don't have a plan, man. I asked myself a question one night. I'm like, I want to make this move without me actually spinning it. I want to make this disc spin without me spinning it. And so I found out how to do that. And that's basically all this is birthed from. That's what it came from.
That's how it started.
That's how it started. I want to make this move automated style.
Yeah.
I don't plan. I don't know, man. Maybe I just should try. I don't think this power, I mean, just looking at this light, I don't know if I want this thing powering my house.
Right.
Not even for a second. But, you know, like, I guess there's a way to stabilize all this energy. But this is not running my house. It's not, no. So at 12 volts now, we're at 93.7 AC volts. I want to use this wire, man. Eddies, man. We need to generate eddy currents. So my typical Utron build is about 9 to 10 days from PCB way. I thought about that, Thomas, and I made the 9-magnet rotor actually with 1 cube magnets, 1-inch cubes. So it has a little bit of added weight along the edge. So there is some flywheel capabilities built right into the rotor, and I know you're talking about an extra flywheel. And yes, as long as there's a maglev, yes sir, the 144 spoke wheel. Yeah, this is a nice wheel. But I need to make a new base for it because it's been spun a lot. Thanks, Zippity. He must have been here when I took the mic to the bathroom.
That was a funny one. Growing pains. 22, 222, 122.
It's 2:22 right now? Oh, 2:22 hours. But we're coming up on 2:22:22 right about now.
Yeah. Congrats.
Wow, what a day.
What a day.
Yeah, I'm definitely planning on turning that one into something special. Definitely going to be something special, but you know, I don't have the financial freedom to build the way I'd like to build. Um, I want to build like a new base, maybe even have it be on the wall.
Mm-hmm.
Have it be one that spins like this. Heck yeah, man. That is truly an amazing piece. I'm glad I found it. And the magnets just fit right on there, like bow down. Attracted right to it. Wow.
I heard that.
It really wants to move. Hey, chicks. Meow. All right. All right. So. Just thinking about forward progression here. Like, is there anything else that I want to do? Because I usually get into taking stuff apart and trying to put something else together, and that's when it all kind of falls to pieces. All right. All right. So, is there anything that anybody would like to see that they need an explanation on or anything? I think it's great. I'm sure it can work better than it's working, but I think it's great. All right.
Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale, and we're working with pulse motors today. Like and subscribe. Let us know if you have any comments.
A mini transformer. This will go up to 345 volts with 10 input. 10 volt input, 345 volts. All you have to do is turn a little screw. Yeah. This is awesome. Look at this baby spin, man. It's going really fast. Alright, I'm going to turn up the input. That's why I got a power supply. Perfect. Alright, check this light out real quick. We're not going to leave it up this long. Get a reading on here. 109, 110. Yes, the negative spike from the SG can handle any load. I'm pretty sure. I mean, like Tesla coil load, it can handle, well, every load that I've tried so far. And then the third strand can handle any weight. I don't know. Like if you're talking about running a PC, I wouldn't even think of trying that. That sounds really just not smart to me. $120. I think that like such should work in correspondence with the grid to get power to everybody cheaply. It shouldn't just be people that know how to do this that get the power. It's just, it shouldn't be like that. $123. But we are at 17.5 and 1 amp. It can do another pulse motor. It can do a light. It can do transformers. It can do tested coils, which is essentially a transformer. I'm gonna print fan blades that will be able to adhere to this rotor right here. Yeah, I never put myself in a box like that. So, I know that all the mathematical equations were done for 12 volts, but I bought a 25 volt power supply so I could transcend that. And it's all good when you're going to do it on paper. Then you stick to your 12 volts. Then it's good across the board. But when you actually apply the power, there's nothing stopping you from turning it past 12 volts. So I don't understand. The only thing that would stop me would be me using a 12 volt battery, and then I'm stuck.
Hey everybody, welcome to the channel. Thanks for coming in. This is Papa Bale. Drop us a like, subscribe. Let us know if you have any comments or questions.
And yeah, man, I mean, like if you're gonna do like a school presentation and you're gonna teach somebody about everything that you've done, and it's like, yeah, this happens at 12 volts, and you're trying to explain it to somebody. Yeah, it's not like, and I'm pretty sure with the voltage increase and the power increase, that all this is going to equal out to the increase in voltage over here, but it's all going to level out. Yeah, the power is exactly the same. I'm not trying to mess with anybody. I'm not trying to change anything, really. I'm just saying that you apply 2.5 more volts, you're going to get 25 more volts over here. And the reason it's like that, is because the amount of copper that's in this coil and the amount of copper well, all I'm trying to say is that the copper in this is approximately 10 times what's on the other side. So we get 125 volts out of 17.5 volts. And it literally has to do with the amount of copper in the coil. The way I'm doing it, I mean, it's totally independent from everybody else, from everything else. It's totally independent. Only gathering electricity from the magnetic induction that occurs when the magnet passes. Yes. Yeah, it's basically a transformer. I've now turned this pulse motor into a transformer. I'm sure there's always something that somebody isn't factoring in when they're like, oh, over unity.
Right. Yep. We did it.
We did it. Oh, we didn't.
There's a calculation.
And seriously, the day that I can just spin it without there being a power supply or a battery or a capacitor, and it continues to spin, that's when we have free energy. That's free energy, ladies and gentlemen. That is free energy. No batteries, no caps, no power supply.
Right.
And not only does it have to spin, but it has to increase in speed. You know, it's got to be a working motor that works for free. That's my idea of free energy. And that's why I know that it's not going to happen. I mean, I can make this spin for 15, 20 minutes on one of my spins just by hooking up the coils a certain way. But it isn't going to last forever. It isn't going to increase in speed. It's going to slowly decrease in speed.
And the argument that monetary energy is a thing.
Oh, yeah. Exponential gains. Here we go. Only when you look on a microscopic level like we are living on is matter not energy. Or I mean, matter is definitely energy.
Sure.
Especially on a huge scale, like if you're looking at a planetary or galactic scale, it's all light anyway. And how that light reflects and bends and other things to create what we see here. Light and dark. You got on, you know, there is an edge to this universe. And beyond that, there is no light. That's a theory. I got most of my copper wire from Amazon. I got a few bits of copper from independent sources. But I mean, like, the last couple, like 10 minutes, we've been discussing very opinionated, theoretical stuff.
Straight up.
Straight up, man. It's all theory an opinion. It's not like written in stone. None of it is. I like that, 125 volts. And I have an even bigger coil than this with 22,000 turns in it. And an iron core. So wow, baby. And when you hook them up in parallel or in series, I bet we could get like 300 volts. And that's just 2 coils. I used to have builds where they go all the way around, man. I had 645 volts coming out of one of my builds.
Yeah.
You know, literally it was running on 4 small coils like this.
Yeah.
That was fun. I really like doing that. And I think I got quite a few hits. I also had a 6 magnet rotor with a north-south, 6 magnets underneath, lined up slightly offset to the magnets on the edge. Man, that one was pretty cool too. Huh. So we got a north-south. Yeah.
Appreciate that. Right in the lab. This is the lab.
Yeah, I'm like, I need to get strong magnets. You know, strong enough to either trigger a reed switch, which isn't that strong. You don't need really strong ones to do that. Or a Hall effect sensor. Ah, they're home.
They're home.
All right. That's awesome.
Here comes Tiggs. Oh, they were shopping. We got
Nice.
big water coming in.
Nice. Oh, that's so good. I can't wait to get some ice, some water.
Yeah.
At least it's not as hot today as it was yesterday. You can see my sunburn.
Yeah.
It's a cockeyed sunburn. This one's more burnt than this one. So I think at 22 gauge, even replacing these coils with 22 gauge will improve everything so much.
Right on, Mr. Roman. That is motivation.
Mr. Roman Timothy. Gotcha. Oh, that's why that's why I don't put myself under that stress of having the goal already planned out before I start.
Yeah.
That's exactly the reason why. Because I'm not gonna spend my life trying to build something that won't work.
So cool.
Just because it worked on paper doesn't mean it's gonna work in real life. Doesn't mean that. You gotta actually do it. And then have it work. That's why I don't like writing stuff down, man. I mean, all that stuff can get really confusing. You gotta be really, really good at doing it for it to be worth doing. What's that say?
Usually there's a family getting in the way. Or, you know what I mean.
Yeah.
That's the wrong way to say it.
Yeah, no. everything works out A-okay. You know, when I'm doing this in my bedroom, I tend to have the kids stay out.
Yeah.
I don't want any accidents happening or them to touch the wrong thing, get shocked, maybe worse. You know, I tend to keep it separate. He comes in, my son, every once in a while, and I let him spin things around, and touch stuff, and try and make sure it's all off when he's doing it.
Yeah. A little pulse motor master in training.
Yeah, and he's the one that's gonna do it all.
Mm-hmm. All right, man, I got about 10, 20 minutes left in me.
Oh, let's not go that long.
All right.
I really want to say hi. All right, so that's really awesome. I think the iron infused PLA, these cores, phenomenal, man. They work so well, and they're like 55% plastic, 45% iron. They work really well. It's like having a little light ferrite core, very on the light side.
Oh, I see. No problem, Mr. Roman.
Dad, is it okay if I practice my soccer outside?
That was the core got sucked in.
Yep.
Dad,
Turn it off?
Yeah, I did.
hey Dad,
Yeah.
is it okay if I play soccer outside?
Yeah.
Okay.
All right. All right. That's a good time to stop.
All right, so you want to do your wrap up?
Yeah. All right. So everything's cool. The core just lost its grip. This is Papa Bale. And thank you very much for tuning in. And this has been Pulse Motor Mayhem. Please come back and join us again. Thank you.